Do you remember how to change radicals to exponents? The cube root of 2 is equal to 2 to what exponent?
1 over 3.
1 over 3. So a square root would be 1/2. A fourth root, if I had the fifth root of x, that's x to the 1/5. So that's an exponent rule that we have to remember as well. So here, if I do that first, I'm going to take my time in 8. I have 2 to the x equals 8, and I'm going to change this cube root to 2 to the 1/3. Now looking at my numbers. Are these numbers all in the same column of one of your powers chart? Yes, you can change the 8 to 2 cubed. And we run into another exponent rule from grade 9. What do you do on the right when you have 2 cubed times 2 to the 1/3? Can you remember if I give you easier numbers? 3 squared times 3 to the 5 is 3 to the 7. If the bases are the same and you're multiplying, we just need to add the exponents. That doesn't change if you have fractions. So I need to add the exponents here. How do you add fractions? Need a common denominator. Are you okay with this 9/3 plus 1/3? Which gives me 2 to the 10/3. And now finally I've got the same base, so x would have to equal 10/3. So if I was doing this slowly, maybe the first thing I would do is change my radicals to fractional exponents. So I changed the square root to 1/2 and the cube root to 1/3. Then looking at 125 and 625, are they in the same column? Yes. This is 5 cubed. It's still to the 1/2, which is still to the 2x plus 1. And 625 is 5 to the 4, still to the 1/3. A power to a power to a power. We're going to have to multiply. So 3 times 1/2 is 3/2 times, and distribute that. You'll get 3x plus 3/2. And on this side, we'll get 4/3. So 3x plus 3/2 has to equal 4/3. If I subtract, I'm going to need a common denominator, so this will be 8/6 minus 9/6. 3x equals negative 1/6. Divide by 3, which is the same as multiplying by 1/3. And we get x is equal to negative 1/8. 1/8. 9 and 10 for practice. Wow. 1/18. I was just pausing there for dramatic effect.